Hi friends! In this video I will be analyzing Bransle from Stravinsky's neoclassical ballet Agon. This piece was written in 1957, which is right around the later period of Stravinsky, which is also when he began merging diatonic idioms like modality and various post-tonal idioms like 12-tone sets, 12-tone rows, sets, etc. And I immediately call this work neoclassical because several movements explore 17th century French court dances like Sarabande and Bransle and Gaillard. And although the ballet music was written for a large orchestra, there is not a moment where the full orchestra plays tutti. There's a focus on the chamber sound here, which we commonly observe in the mid to late period Stravinsky. Let's first take a listen. So here, the first thing to look for in a general form analysis, as you know, as always, is to look for clear divisions that are provided by the composer themselves. So in this case, I'm observing 3 moments of absolute halt throughout the piece, not including the rest in the very beginning, where nobody except only one person plays, which is who is castanet. And I'm curious if those moments may be where my larger divisions are indicated by the composer. And there is one more moment that the ensemble sounds like it stops, but the upper voices are still playing and the strings are resting. But these moments are immediately responding with marking gesture on tenuto, like they're marked. And they're repeated twice. So I'm curious if that'll be another section divider that'll help me with my form analysis. So in my intervallic analysis then, as I'm expecting to see various pitch classes, I will keep in mind these markers that I just mentioned to see if Stravinsky will change his pitch material as he switches from one section to the next. I'm also noticing that bars 1 to 5 and bars 6 to 11 are, they look alike, as well as 23 to 25 and again 1 to 5. And although I haven't provided a complete pitch analysis here, I'm seeing enough similarities in the rhythmic motifs as well as their overall intervallic structure. Like, look at the minor and major thirds there in the changing meter, there's multimeter, we clearly can see that. And I'm anticipating that so far that 6 to 11 and 23 to 25 may be like a variation of 1 to 5. We will see. So far, you also probably already noticed that there is a repeating rhythmic ostinato in the castanet part, that even the rest of the ensemble stops, it just keeps that pattern going. So the castanet part won't affect our structural and pitch material arguments because of this, because, I mean, it just keeps going, it never stops. But it will be important for our rhythmic and metric analysis, of course. Speaking of which, notice that the multi-metric writing is gone from bars 12 to 20, which makes me believe that it'll be a section by itself. Or it might be part of a larger section. We'll see that. So far, based on just purely looking at this piece, my expectations for the larger formal structure of this work is like this. 1 to 5, A. 6 to 11 looks similar enough, A prime. 12 to 20 looks like a B. I mean, it's definitely contrasting, and it keeps going again. It does not stop. 21 till 22 may be a part of a B, but so far it looks different enough to me that I'm going to call it C with a question mark. If the pitch material is almost the same as the previous or the following section, I might consider it to be part of either. We'll see. And at the end, we have what looks like an A prime prime for 23 to 26. It may be a coda. We'll see. It's short enough. So in order to make sure that my intuition is correct, I want to first provide a pitch class analysis of each section. As you remember, in set theory, the order of pitches don't matter, so nor does the octave, as you know. So just let's go ahead and write the integer notation for each anticipated section. So let's start with 1 to 5. So we have B, D, E flat, and F for flutes. And for bassoons, we have C, B flat, and F. And for harp, we have B, D, C, and E flat. So far, for bars 1 to 5, our pitch class set looks like B flat, B, C, D, E flat, and F. If we write this on integer notation, that would give us TE0, 2, 3, 5. We want to make sure that it's in its normal order, and it actually looks like it is already in its normal order. And after that, we want to find our prime form to see the intervallic relationship so that we can later find the interval class vectors. So our prime form here is 0, 1, 2, 4, 5, 7, the normal order that is the best normal order that is transposed down to 0. 0, 1, 2, 4, 7. And then it would help to find the fort number from our index, which of course we don't need to memorize. And our prime form here is 6Z11. You can check on the list. You can just look up fort numbers online and the list will come up. All right, so let's move on. Now that we know that the order and octave does not matter, just instead of analyzing each voice, I'm going to go ahead and look at the pitch content of this passage as a whole. The passage of 6 to 11 as a whole, similar to what I did for 1 to 5. So 6 to 11 is D, F, B, E flat, C, and B natural. And its normal order, that would be T, E, 0, 2, 3, 5. And let's go ahead and put that in our prime form, and that's going to give us 0, 1, 2, 4, 5, and 7, which is also the prime form that I found for the first bars, for the first 5 bars. So this is definitely a recurring set. We are sure of that. I'm going to go ahead and call this set A. So notice that we have the exact same pitch material for our second passage here. And given that 6 to 11 followed by a very similar rhythmic motif structure to 1 to 5, and that it had the same pitch collection, as I was just saying, not only the same set in their prime form, but even the actual pitches are the same. That's important to catch there. So yeah, this confirms that 6 to 11 can be labeled as A prime because our pitch content is the same, rhythms look quite similar. So if I call 1 to 5 as A, 6 to 11 can be A prime. So far we have A and A prime. The biggest reason why I didn't call 6 to 11 as a repetition of 1 to 5 was the way that the meter has been subdivided. As you already know and noticed here, both A and A prime sections follow changing meter or multimeter. And with the ostinato and the castanet, it creates some polymetric textures. So the downbeat of the castanet's measures are often out of sync with the rest of the instruments, as you can tell, and although it repeats the ostinato exactly as is, we experience it as polyrhythms. So the cool thing that Stravinsky did here is that the total number of beats in A and A prime is the same. We have a 7/16, 2 5/16s, and another 7/16 for section A. And notice that we have 5/16 and then 2 7/16s and another 5/16 for A prime. So in total, they both have 2 7/16s and 2 5/16s. But it is the changing meter here, changing meter quality, that changes the quality of the rhythm and hence the type of the groove that we're experiencing here. It destabilizes the temporality of the passage here just enough that we simply can't ignore it for our structural analysis. It's different enough. So yeah, that's why 1 to 5 is A and 6 to 11 is A prime in my analysis so far. Let's move on to bars 12 to 20. So our pitch collection in this section is C, G, F, B flat, A flat, B, E, F sharp, C sharp, A, E flat. Yeah, there are a lot of notes going on here.
It's quality work. And there are simply too many notes. That's all. Just cut a few and it'll be perfect.
Well, it's clear that we are not observing an immediate set or an immediate relationship to set A. So I guess we're going to have to explore a little bit more. So let's look into each voice and see if there are any correlations, or if Stravinsky might be giving us some sort of a 12th tone row. Again, he might be. This hexachord in bars 12 to 13 looks like it's repeated in 14 to 15, so that might be important to look into that set. So yeah, C, G, F, B flat, A flat, and B repeats. So in integer notation we have 0, 7, 5, T, 8, and E. In its normal order, that would be 5, 7, 8, T, E, 0. So that does not look like it's the best normal order. So let's go ahead and find the inversion of this. So our inversion would be 0, 1, 2, 4, 5, 7. Well, would you look at that? So our prime form is also 0, 1, 2, 4, 5, 7. So yeah, here comes the set from A back, actually. So yay. This section also started with set A. So what happens next in the flute line? There's a C, E flat, D flat, A flat. There's another C sharp, but that's D flat, and G. Well, I'm curious if these pitches would give us a 12-tone row when combined with the first set of the section B, which was set A. But it looks like they're actually sharing pitches. Yeah, they both have A flat and C natural. So yeah, that easily convinces me that this movement, in a way, is less interested in a 12-tone structure, and could be expected from Stravinsky. But yeah, this is less interest in 12-tone, but more on exploring various sets, I guess. But they still might be Z-related, as in they might be sharing the same interval class vector and therefore sharing the same intervallic content. They also might be complementary hexachords of one another, as in they can complete the 12-tone chromatic scale when correctly transposed or inverted. So going back to the second half of the flute part then, our pitches were a C, E flat, D flat, A flat, and G. In integer notation, that would be 9, 0, 3, 1, 8, 7. In normal order, that would be 7, 8, 9, 0, 1, 3. Let's transpose it down to 0, 0, 1, 2, 5, 6, 8. 0, 1, 2, 5, 6, 8. Okay, let's call this our set B. What I want to do now is look into set A and set B, and I'm going to compare their interval class vectors to see if there are very obvious intervallic relationships between the two sets. So interval class vector of our set A, 0, 1, 2, 4, 5, 7. So 0 to 1, we have 1, 0 to 2, 0 to 4, 0 to 5, 0 to 7. 0 to 7 is a 7, but remember from the previous video, we find the complement of it, which is 5. 1 to 2 is 1, 1 to 4 is 3, 1 to 5 is 4, 1 to 7 is 6. 2 to 4 is 2, 2 to 5 is 3, 2 to 7 is 5. 4 to 5 is 1, 4 to 7 is 3, and 5 to 7 is 2. So we have 3 1s, 3 2s, 3 3s, 2 4s, 3 5s, and 1 6. That is 3 3 3 2 3 1. And fourth number for that would be 6Z11. 6Z11. And for the vector B, interval class vector of set B, we have 0, 1, 2, 5, 6, 8. So 0 to 1 is 1, 0 to 2, 2, 0 to 5 is 5, 0 to 6 is 6, 0 to 8 is 8, but it's going to be 4 as you know now. 1 to 2, 1, 1 to 5, 4. 1 to 6, 5, 1 to 8 is 7, but that shall be 5. 2 to 5 is 3, 2 to 6 is 4, 2 to 8 is 6. 5 to 6 is 1, 5 to 8 is 3, and 6 to 8 is 2. So we have, how many? 3 1s, 2 2s, 2 3s, 3 4s, 3 5s, and 2 6s, it looks like. So our interval class vector of set B would be 3 2 2 3 3 2, and the Fort number for that is 6Z43? 43? Yeah, 6Z43. The Fort number is only going to help me when I'm comparing my results later. Instead of dealing with a lot of different numbers, I can just look at the Fort number and see if there are obvious correlations. And then I can check back on my list. So, yeah, sets A and B actually look like they not only have different pitches, but they also have completely different intervallic structures because we didn't get the same interval class vector. So they're not transpositionally or inversionally related, we already saw that, but they're also not Z-related either. And they're also not hexachordal complements of one another, because if that was the case, we would see them in Fort's pitch class table, like next to one another. But we only looked at the first flute passage so far, so I want to see what's going on in the rest of the voices. So we've already seen that the pitch collection of the whole section gave inconsistent results. So I guess we can try to look at different segments to check for other relationships. So if you look at both clarinet lines and bars 16 and 17, I will consider that flute 2 line to be a part of the segment in bars 16 and 17 with the clarinet, or possibly just consider it as a part of the chromatic contrasting middle and call it chromaticism there. And obviously I cannot make an argument until I look at all possibilities here. But one thing that we can definitely be sure of is that we're seeing the full chromatic scale in this section, no matter what kind of sets we're looking at, or whether there are consistent statements of a recurring set or not. So all 12 pitches are definitely there. I'm still curious though if the clarinet lines are related to one another. So let's look at clarinet 1, bar 16 to 18. C sharp, E, D, G, F, and C. That would be another 0, 1, 2, 4, 5, 7, right? Yeah, hooray. Yeah, that's set A again. That's fantastic. So clarinet 2 from bar 16 to 18. This is not a hexachord though. There are 7 pitches there. Let's still look into that though. So F, D, G, A, E, F sharp, E flat. That'd be 5, 2, 7, 9, 6, 3, 4. Let's put it in its normal order. 2, 3, 4, 5, 6, 7, 9. And that in its prime form would be 0, 1, 2, 3, 4, 5, 7. Well, this segment is actually interesting because notice that the E flat at the end of this passage is the only note that doesn't fit in set A that we just saw, the 0, 1, 2, 4, 5, 7. So 3 does not fit there. So, as I was saying earlier, let's see if that E flat can be reinterpreted as the beginning of a new phrase or part of a different segment. So notice that where this E flat is, we're also hearing the C from clarinet, A and C from flutes, which looks like the beginning of another short segment, actually. So if you look at the passage that begins with the E flat, that would give you E flat, C, A, B flat, and D flat. In integer notation, unordered, that would be 3, 0, 9, 10, 8, 1. Put it in normal order, 8, 9, 10, 0, 1, 3, and our prime number, yay, 0, 1, 2, 4, 5, 7. So yes, it comes set A again, and that E flat actually would be considered following in the following passage rather than in the previous passage. So when I call the previous set as not a hexachord, it actually was a hexachord. Stravinsky just decided to end the passage with the beginning of a new segment. So here we are once again consistent with our set A. All right, so in this passage in section B so far, we've seen various statements of pitch class set A and some Z-related sets to set A after we did the interval vector. And as well we saw 2 new segments there, which neither of which were actually transpositionally or inversion related to A or Z related. And finally, bars 21 and 22. As I was saying, we could probably consider these two bars as part of B section, as it's a very short passage. But so far I haven't, simply because we might be observing a set here that we haven't seen before. So let's see. So in the chord in bar 21, I see A, G sharp, F sharp, C sharp, E, G. 9, 8, 6, 1, 4, 7. Let's put it in its normal order. 6, 7, 8, 9, 4, 8, 9, 1, 4. Yeah, that is not the best normal order. Let's try 1, 4, 6, 7, 8, 9. That doesn't also look good. Let's try its inversion. 3, 4, 5, 6, 8, E. Yeah, that looks like the best normal order to me so far. 4 minus 6. Yeah. 3, 4, 5, 6, 8, E seems like our best normal order. Let's transpose it down to 0. That would be 0, 1, 2, 3, 5, 8. So this set in its prime form has not been observed yet in our piece. I'm curious if it's going to be Z related to any of the set A or set B. And let's call that set C. So 0, 1, 2, 3, 5, 8. So 0 to 1, 1, 0 to 2, 2, 0 to 3, 3, 0 to 5, 5, 0 to 8 is 4. 1 to 2, 1, 1 to 3, 2, 1 to 5, 4, 1 to 8, 7, but 5. 2 to 3, 1, 2 to 5, 3, 2 to 8, 6, 2 to 3 to 5, 2, 3 to 8, 5, 5 to 8, 3. So here we have 3, 3, 3, 2, 3, 1. Excuse me. And our fourth number is 6Z40. Oh, yeah, 3, 3, 2, 3, 3, 1. Fantastic. Well, yeah, notice that the interval class vector of set C and set A are Z-related here, aren't they? Yeah, they both have different pitches in them, and they're even labeled with different numbers as their different sets, but intervallically they're the same. They also are the complements of one another. If we look at this fourth set class table, as I was saying earlier, if they're next to one another, if they're in the same line, that reminds me that they're going to be hexachordal complements of one another. So yeah, this means when they're taken together, they can complete the 12-tone chromatic scale if they're correctly transposed and inverted. So the pitches are different, but if we were to transpose or invert them just like right to the right temperature, I was going to say, to the right number, we would get two hexachords that would be that would have hexachordal combinatoriality. That would make the full chromatic aggregate. Anyway, so set C, didn't we see set C before? It was foreshadowed in bar 19 in the clarinet parts. If you look at bar 19, we have D sharp, A natural, F sharp, G sharp, and B. Integer notation, that would be 3, 10, 9, 6, 8, 11. Put it in normal order, 8, 9, 10, 11, 3, 6. Let's try the other way around. 3, 6, 8, 9, 10, 11. 8 minus 3 versus 6 minus 8. Yeah, 8 minus 3 is a much shorter distance, obviously. So it's going to be 3, 6, 8, 9, 10, 11. But that does not look good. I'm going to find its inversion. It doesn't look good because, 3 to 6 is a 0 to 3 jump. That's not the most compact. So let's find its inversion. Inversion of 3, 6, 8, 9, 10, E. 8, 9, 10, E. And our inversion would be 9, 6, 4, 3, 2, 1. Put it in normal order, 1, 2, 3, 4, 6, 9. In its prime form, it's 0, 1, 2, 3, 5, 8. So yeah, that is set C. That was already observed in bar 19 in the clarinet parts. But this set, when it was in bar 19, didn't have an immediate function yet, other than completing the chromatic aggregate, and pretty much introducing our ears to the sonority of this chord in bar 21. So bars 21 and 22 then could be considered as a short section of itself, I guess. but texturally it is completely different, right? But because it's the same set as we saw in 19, it could be considered part of section B too, as it marks a sense of like a halt, as we were saying earlier, similar to the earlier section divisions through the 3/8 rests. But the pitch material is also Z-related to the pitch material of section A, so I don't know, it's very short. I don't know if it'd be logical to call that part a section of itself. I think I will label it as part of section B. Yeah. So then 12 till 22 would be our part B, section B. And bars 23 through the end is a very short return of the A section, as you can very clearly tell. Same pitch material, but it's much shorter, so I guess we can call it an A prime prime. Given its length, you could also call that a codetta or a coda. That would be up to you. I think I will call that A prime prime. So to wrap up, overall in this piece, we've seen two unifying elements so far that recur throughout the piece. One of which was a set A, which was a basis for various other segments that were transpositionally and inversionally related, as well as Z-related, where they shared the same intervallic content but were not transpositional or inversionally related, which is, again, a definition of Z-related. So, section A explored set A, 0, 1, 2, 4, 5, 7, and repeated once in section A prime with slight modifications. Section B had various transposed and inverted statements of set A, as well as a new set, which we called set B, 0, 1, 2, 5, 6, 8. Set B had nothing to do with either of the sets, right? The set A was actually Z-related to the last segment that we found, the set C, 0, 1, 2, 3, 5, 8, as they share the same interval vector. And set A came back through the short return of A, obviously. The other unifying element was the ostinato. The sections were clearly divided by metric and rhythmic differences, but the ostinato has never stopped, which created polymeters along with the multimetric writing and the rest of the ensemble. Let's take a listen to the piece one more time, watching the chart analysis. So, throughout this video, I personally argued that bars 1 to 5, bars 1 through 5 and 6 through 11 were similar to one another, and that supported my argument by looking at the pitch content there, as well as the rhythmic devices. And because of the continuous textures between bars 12 and 20, I argued that we cannot divide those sections within that passage. So then we had an A that was equally divided, and then a B that could not, it's 12 to 22, excuse me, that could not be divided, which was section B. The pitch content in this section showed similarities to section A, as it brought our set A back, but there were enough inconsistencies in there, like no set that was not related to A, as well as various pitches that was not fitting fully, was being treated as part of a new set. So that eventually made me consider this whole passage as possibly exploring chromaticism within the narrative, with several statements of set A in transposition and inversion. The final set in section B was introduced in bar 19 in the clarinet part, which was stated again homophonically in bars 21 and 22, which again made me consider bars 21 to 22 as part of section B because of their intervallic similarity to bar 19. And I decided to call bars 23 to 26 as A prime prime, simply because it brings an incomplete version of section A, as I think coda could imply new material or new set, which is not the case here. But if you could support your argument that it would be a coda, be my guest. So this is the amount of detailing that I would like to see in your analyses or analysis projects. It's okay if the composer is inconsistent or quote-unquote wrong with the way that they're treating some of these like sets, and all you have to do is look for the evidence. Like, it does not matter, in other words. Like, if the evidence shows you no unity within the piece, and luckily most of these pieces will actually have some sort of unity, but even then it would be okay. Like, remember, it was okay for Beethoven as well, like with the way that he treated sonata form. And always remember that a composer might be just writing a piece. Remember the Tomachko quote. And the composer might not be necessarily focusing too much on the mathematical perfection in their piece. Like, Xenakis' music has an insane amount of high mathematical relations, but sometimes he would just break his pattern, and that would be simply because he doesn't like the way that it sounds sometimes. So at the end of the day, like, our arguments should always come to, like, what is this craft doing to our experience of the piece? Why does this piece work? How does this piece work? And I'm not saying our enjoyment of the piece, but I'm saying, like, our experience of the piece. Like, again, what does it mean, you think, like, that Bransle from Agon has, like, loose ternary or rounded binary with coda? Like, what does that mean? Well, maybe when that's the question, rephrase your perspective and like, instead of going all structuralist and just trying to explain based on, like, little segments, going all microstructural, think about the bigger picture. I hate that statement. I don't. Well, anyway, but this is a ballet piece, right? Like, where the movers, the dancers need to be able to count. And thanks to Stravinsky's love for multimeter and polymeter, it would be very difficult to count in a piece like this. But maybe that is why the castanet ostinato isn't there, right? It just keeps feeling in 3/8. Like, it simultaneously provides an ease for the dancer to count and move, but also highlight that quintessential Stravinsky sound. And also remember that this is a Bransle, which literally translates as swaying, a traditional French court dance with a number of, like, large steps, like to the left alternating with to the right, like left, left, right? I mean, I don't dance Bransle, but we all basically know. So, like, even in the music, there's a sense of equal left and equal right motion. So maybe, like, that explains the repeated A with modifications? I don't know. Like, as in bars 1 to 6 indicating steps to the left, 6 to 11 steps to the right? No clue. I'm not a ballet expert. I'm just making educated guesses based on the musical evidence and based on my extremely limited knowledge of dance. But of course, you would not be talking much about what you don't know. You can only do more research on it. And the interpretation level of it is good, but it's not going to be the most necessary thing in your analyses. It's going to be more about the musical evidence. I don't know, or like maybe the swaying quality of the contrasting middle, as I was saying, like Bransle means swaying. This would definitely cause issues with the rhythm, right? But that might be why Stravinsky brought the repeated tenuto in bar 21, like maybe as a mark or cue for the dancer after all the craziness, all the frenzy. Bomb, bomb, here's a cue, get back to your tempo. Again, at the end of the day, I don't know what difference it really makes other than, like, enhancing our experience and the appreciation, or our appreciation of the piece. But, I mean, yeah, once again, that's it. Like, theory is 50% nerding out, and I guess academia is 100% nerding out. So, the fun thing about analysis is that, like, it shapes our understanding of the aesthetic there, which we may or may not be familiar with. So post-tonal analysis then is not just about set theory or weird sounds or like interesting tone rows, or it's not only about that, it's about understanding why a piece works. And you're welcome to not even enjoy it, and then thankfully, like, that says absolutely nothing about the quality of that work. And it's totally okay if you think that a piece even does not work. Like, that could even be your argument, because some pieces simply might not work. But remember, that's not a taste-related statement. Like, I don't like this, or I don't care for this is different than this piece does not work. If you say that a piece works or does not work, you have to justify your answer. Like, it's not you, it's the work that has the evidence. And if you ignore the evidence and come to conclusions without musical evidence, you may just get away with it, but it would be academically ignorant. And in the case of Stravinsky, again, the commentary on if it relates to dance or not is personal interpretation. And again, it can help you understand it on a personal level, but what you need to stick to is the musical evidence.